So today we're going to be doing Phi 1 and Phi 2, which is all about probability distributions. So before we get started, some definitions we need to go over. So a random variable is variables whose values are determined by chance. So there are two types of random variables, a continuous and discrete random variable. So a continuous random variable can take on infinitely many values. So a person's height is a continuous random variable because it could be any height in between, right? You could get decimals and all the numbers in between them. And an example of a discrete random variable would be counting the number of heads when flipping 3 coins. So if you flip a coin 3 times and you count the number of heads, well, it only can be 0, 1, 2, or 3, and nothing in between. You can't get a 1.5 or anything of that. Okay, so then in these two sections, we're going to be focusing on the discrete probability distribution. And the discrete probability distribution has the values that the variable can assume and its corresponding probabilities. So for example 1, we need to construct a probability distribution for rolling a single die. Okay, so when we roll a single die, our random variable x can take on the values of either 1, 2, 3, 4, 5, or 6. All right. And then the probability of all of this. Okay. So if you have a fair die and you roll it, every number has an equal chance of being rolled. So there are 6 sides to the die. Everyone has an equal chance. So then 1 has a 1/6 chance. 2 also has a 1/6 chance. And 3, 1 out of 6. 4 is 1 out of 6. 5 is 1 out of 6. And 6 is also 1 out of 6. So some properties of a probability distribution is all the probabilities will be in between 0 and 1. In this case, they're all the same. If they were different, they would be in between 0 and 1. And then the other important property would be that the sum of all these probabilities equals 1. So if you take 1/6 and you add 1/6 and you add another 1/6, 1/6 plus 1/6, 1, 2, 3, 4, 5, one more, 1/6. So you take all the probabilities and we're going to add them all up. Since they all have a common denominator, you just had to add the numerators. So you add up 1/6 times, and you get 6 out of 6, which is equal to 1. So in general, for any probability distribution, a discrete probability distribution, the probabilities will be in between 0 and 1. And if you add up all the probabilities, you should get a 1. So example 2. So let the random variable x be the number of heads when flipping 3 coins. And then we have to construct the probability distribution for the random variable x. Okay. So first, let's recall the sample space for flipping 3 coins. So the sample space, S. So if I flip a coin 3 times, it could come out all heads. You could get head 3 times in a row. Or maybe you get heads, heads, tail. Or you get heads, tail, heads. Or maybe you get tails, heads, heads. Or you could get tails, tails, heads. Or you could get T, H, T. Or you could get heads, tails, tails. And finally, tails, tails, tails. So that there is the sample space for flipping a coin 3 times. Okay, and then our random variable is going to be the number of heads in these flips here. So if you count, we got 1, 2, 3, 4, 5, 6, 7, 8. 8 things in our sample space, and all of them are equally likely. Okay, so x is going to be the number of heads when we flip 3 coins. So it could be 0 heads, or it could be 1 head. All 3 of these have 1 head. Or it could be 2 heads, or it could be all 3 heads. So you could have 0 heads, 1, 2, or 3. Okay. And then the probabilities, P of x. So the probability of no heads would be getting all 3 tails, and there's one of those out of the total 8. So the probability of no heads is 1 out of 8. The probability of getting exactly 1 head would be one of these 3. So there's 3 of them out of the 8. So then it'd be 3 out of 8. And the probability of getting 2 heads would be these 3 here. And there'd be 3 again out of 8. So 3 out of 8. And the probability of getting 3 heads, that'd be heads, heads, heads. So then there's only one of those, 1 out of 8. So if you look at the probabilities, they're all in between 0 and 1. And then if you add them all up, you take 1 plus 3 is 4, 4 plus 3 is 7, and 7 plus 1 is 8. You get 8 out of 8, which is 1. All right, so example 3 is a relatively hard example. All right, so a convenience store sells AA batteries, and it sells them in a 2-pack, a 4-pack, a 6-pack, and an 8-pack. So in one day, the store sells 5 2-packs, 10 4-packs, 8 6-packs, and 2 8-packs. And we need to construct a probability distribution. So X is going to be the packs that we sell, okay? The number of packs that we sold. So X, so we could sell a 2-pack, or a 4-pack, or a 6-pack, or an 8-pack. Okay, those are all the different packs we can sell. And then we want to know their corresponding probabilities. Okay. So first we need to figure out the total number of packs sold. Okay. So in the day we sold 5 2-packs, and we sold 10 4-packs, and we sold 8 6-packs, and we sold 2 8-packs. All right, and then we're going to add these up to see the total number of packs that we sold. And if we add this up, you get 8 plus 2 is 10, 10 plus 10 is 20, 20 plus 5 is 25. So in total, we sold 25 different packs. Okay? So if I want to know the probability that we sold a 2-pack, well, we sold 5 of those out of the 25. So we get 5 out of 25. If you punch that into your calculator, you're going to get 0.20. All right? And then for a 4-pack, the probability that we sold a 4-pack, well, we sold 10 of those out of the 25. So if you put 10 over 25 into your calculator, you're going to get 0.40. And then for the 6-packs, so we sold 8 6-packs, so 8 out of the 25. And if you put 8 out of 25 into your calculator, you get 0.32. And then for the 8-packs, we sold 2 of those out of the 25, and 2 divided by 25 is going to give you 0.08 right there. So there's the probability distribution. If you note, all the probabilities are in between 0 and 1. And if you're to add up all the probabilities, this would be 60%. And if you add these two up, you get 40%. And 60 and 40 gives you the 100%. Okay. All right. So in example 4, we need to determine if this is a probability distribution. So the two key things is all the probabilities are in between 0 and 1, and the sum of the probabilities equals 1. So if you look at the probabilities, the first one is 0.3, 0.4, then 0.1, and 0.2, and 0.1. So all those probabilities are in between 0 and 1, but that doesn't guarantee us that it is a probability distribution. You also have to check that they add up to 1. So the first one was 0.3, and we have to add the 0.4, and then add the 0.1 plus the 0.2 plus the 0.1. Okay, so then if we add all this, here we get a 0.7, so 0.7, plus, add these two, you get a 0.3, and then we're going to add a 0.1. So now if you add these three together, this is 1, and then you have a 0.1, so all in all is 1.1, which does not equal 1. Does not equal 1. So even though the probabilities are in between 0 and 1, since the sum adds up to more than 1, in this case, this is not a probability distribution, right? So it is not. So not a probability distribution. Probability distribution. Whoops. Distribution. Because the sum does not equal 1. The sum does not equal 1. Does not equal 1. 1. All right. There's that one. So, okay. All right. So for example 4b, here we have another probability distribution. Note that our variable is not quantitative. It is qualitative or categorical, right? So X here is going to be spades, diamond, hearts, or clubs, which are things you could draw out of a standard deck. And in this deck, it looks like they pulled out some cards out of this deck here based off these probabilities. Okay. But the question is this a probability distribution? So you look at all the probabilities. So you have 1/4, you have 1/2, you have 1/8, and you have 1/8. So all those probabilities are in between 0 and 1. And then the next thing you need to check is if you add them all up, do you get 1? So here we got some fractions. So you guys have calculators. You could just plug it into your calculator and use your calculator to get it. But I'm a fan of no calculator. So here the least common denominator will be 8. So I need to change this 4 into an 8. And the way you do that is you got to take 1/4, and then we got to multiply the denominator by 2. Whatever you do in the denominator, you have to do to the numerator. So you put a 2 over 2 there. So essentially you multiply by 1, and you didn't really change the 1/4. Plus 1/2, so we have to change the 2 into an 8. So how do you do that? You multiply 2 by 4, and whatever you do in the denominator, you have to do in the numerator. And then plus the 1/8 plus the 1/8. Okay. So then multiply the numerators and the denominators. You get 2 over 8 plus multiply numerator and denominator, 4 out of 8. And plus, we didn't change these, 1/8 plus 1/8. Okay. All right, so then now if we add all these up, we get 2 plus 4 is 6, and then 7, 8. We get 8 out of 8, which is 1. So then, yes, this is a probability distribution because all the probabilities are in between 0 and 1, and the sum of all the probabilities gives us 1. So for example, for C, we have this distribution here, which kind of reminds me of when you're combining genes and whatnot, like a Putnam square. So let's see, the probability of BB is 1/4. And the probability of BG is also 1/4, and GB is 1/4, and GG is also 1/4. Okay, so all of the probabilities are in between 0 and 1. So then we need to check their sum. So we add them all up. So then this is nice because all the denominators are the same. So you just have to add the numerators. So indeed you get 4 out of 4. Which is 1. So this is indeed a probability distribution because all the probabilities are in between 0 and 1, and the sum of the probabilities give you 1. Okay, so here's another probability distribution, for example 4D. All right, So probably off the back you can see something is odd here. So the first probability is negative 0.2, and then our second probability is 0.3. Our third one is also 0.3, and the last probability is the 0.6. Okay, so from the get-go, there's something wrong with this one here, and it's negative, and probability cannot be negative because it has to be in between 0 and 1. So you don't even have to add them all up. You already know it's not a probability distribution because you have one negative probability. Let's see. And then the same thing would occur. Let's pretend if I change this. So same thing would occur if you had one of them as 1.3. So then that is also going to cause a problem because this probability is more than 1. So in those two cases, you wouldn't have to add them up because if you get negative or more than 1, you already automatically know it is not a probability distribution. Okay. So essentially that was 5.1, which I think is relatively easy. So then this is the start of 5.2. And here we want to figure out the population mean and the population standard deviation, or population variance, for discrete probability distributions. And these are the formulas that we're going to be using to calculate the probabilities. All right. So here we want to find the population mean and population standard deviation for example 2. And I put the probability distribution from example 2 right there. So if you're trying to check your work, that should be the correct answer right there. So we want to find first the population mean. All right, so the formula we have for the mean, mu, it's a population mean. So the formula for the population mean is mu is equal to the sum of x times p of x. All right, so that's the formula we have. There's the probability distribution. I'm going to copy the distribution here just so I could use it. So x, so we're rolling a die, and when we roll a die, the possibilities were 1, 2, 3, 4, 5, and 6. And the probability of each one of them was 1/6. So the probability of each was 1/6, 1/6, 1/6, 1/6, 1/6, and 1/6. Okay, so what this formula means right here, so sum, this is the capital letter sigma in the Greek alphabet. So we're going to take the sum, we're going to add a whole bunch of things up, and what are we going to add? We have to multiply the x value times the probability of its corresponding probability. So for example, mu is going to be, so you take the x value and you multiply by the probability. Be 1 times 1/6 plus, so the capital sigma means add, and we're going to add the next one. So the x value times its probability. 2 times 1/6 plus the x value 3 times its probability. 3 times 1/6 plus 4 times 1/6 plus 5 times 1/6 plus 6 times 1/6. All right. So we have that lovely formula to calculate the mean. Okay. So then mu, so first we do the multiplication here, order of operation, multiplication before adding addition. So here you get 1/6 plus 2 times 1/6 is 2 out of 6 plus 3/6 plus 4/6 plus 5/6 plus 6 out of 6. Note that I'm not simplifying any of the fractions because they already have a common denominator, and I don't want to refine that common denominator. So only simplify at the very end. All right. So now we got to add all this stuff up. So mu, let's see. Let's work. I guess we'll start from the beginning. So since all the denominators are 6, you could just add the numerators. So it's going to be 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 5 is 15. 15 plus 6 is 21. So you get a 21 out of 6. So this is the one you would simplify. So then mu, the population mean. So here, 3 divides both of them. 3 goes into 21 7 times. And 3 goes into 6 2 times. So if you like decimals, you get that mu is going to be, that's going to be 3.5. 0.5. And that is how you calculate the mean. Let's see. So recall that the mean is 3.5, and we're going to use that in a little bit. So we just found the mean, and the mean was 3.5. So mu is 3.5. So there's 2 parts of this question. So the first one said find the population mean, and the second part says find the population standard deviation. So next, we're going for the population standard deviation. To get that, first we find the population variance. So that's going to be sigma squared. And that is equal to the sum. So the formula is x squared times p of x. So you have to do all of that. And then you have to subtract off mu squared. So that's the formula we'll be using to get the population variance, which will help us get the population standard deviation. So note that in the formula, so we already have the mu, that's good. We already know the probabilities, they're all down here. The other thing we need is the values squared, the x values squared. So then what I need of all of these right here is the squared values here. So I'm going to squeeze this in over here. So I'm going to make an x squared column, and I'm going to square all of my x's. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. And 6 squared is 36. 36 there. Okay. So now we have all the squared values. We have their probabilities. And we know the mean is 3.5. So now we can apply this formula here. Okay. So again, this capital sigma means add. So we're going to be adding up a whole bunch of things. And this is what we'll be adding. The squared times the probability. Okay. So sigma squared, the variance, population variance, is going to be 1 times the 6. 6 plus the 4 times the 6. Plus 9 times a 6 plus 16 times 1 6 plus 25 times 1 6 plus 36 times 1 6. All right, quite involved. 1 out of 6. Okay, so again, we're just going to multiply the number and the numerator to get into one nice fraction. So we get sigma squared is 1 6 plus 4 6. And again, I'm not going to simplify the denominators or the fractions until afterwards. So this is going to be 9 6 plus 16 out of 6 plus 25 out of 6 plus another 36 out of 6. So I would use a calculator at this point in time to add these up, but unfortunately I don't have one of those on hand right now. So I have to do that right here. It's not too bad. So if I add 9 and 16, that's 25. So then 25 plus 25 is 50. So these right here are 50. And then these two is 5, so that's 55. So then you have 55 plus 36. So 55 plus 36 should give you a 90, let's see, 55 and 36, 91 I believe. Let me do it out here to make sure. So 55 and 36, if you add, yeah, 11, carry the 1, 8 and 9, 91. 91 out of 6. 91 out of 6. So we don't need this part anymore, so I'm going to erase it. Okay. So 91 out of 6. So Oh, and then you can't forget, so in all of these, what were you supposed to do? I forgot something. So if you're going to write sigma squared, you have to subtract off mu squared. So all of these are minus the 3.5 squared, which I like the fraction form, minus the 7 over 2 squared minus, so if you square 7 squared is 49, and 2 squared is 4. So then here you have to also subtract off 49 out of 4. So yeah, we would use a calculator here to calculate this here. Let's see. So using a calculator, we got this turns out to be 35 out of 12. I'm running out of space, so let's move that. So sigma squared, let's see, what did I say? I said 35 out of 12. 35 out of 12 is right there. And then the decimal form of that, if you round it to 2 decimal places, it's 2.92. So I guess it's approximately 2.92. So that right there is the population variance. And if you want the standard deviation, then you got to take the square root of all this. So sigma, regular old sigma, is going to have to be the square root of 2.92. So then, using the calculator again, let's see. We get the square root, 2.92. Comes out to be 1.71 if you round to 2 decimal places. So approximately again. So now we need to find the mean, the population mean, and the population standard deviation for example 3. And I pulled up the probability distribution for example 3. So that was the battery one, if you recall. Okay, so then again, I'm going to recopy the distribution here. So X is going to be the number of packs we sold. So we sold the 2-pack, the 4, and the 6, and the 8-pack. And then their corresponding probabilities are, let's see, P of X. So corresponding probabilities was 20%, or 0.20, and then 40%, 0.40, and then 32%, and then 8%. 8. That was the probability distribution that we got for the battery example. Okay, and now we wish to find the population mean and the population standard deviation. So again, the population mean, if you're given a probability distribution and you want the population mean, then this is the formula you got to use. Is that one right there. And what that means is you're going to multiply x times p of x. So x times p of x, you're going to multiply all of them. And then sigma means add. Then you're going to add them all up. So this will give us, so x times p of x, that's going to be 2 times 0.2, 0, plus 4 times 0.40, plus 6 times 0.32, plus 8 times 0.08. There we go. All right, so there's a long formula there. And we got to multiply through. Okay. So here you get 0.40 plus, if you multiply this one here, I believe we should get a 1.60 plus, so now I'm going to use a calculator to do these here. So it's going to be 6 times 0.32. Yes. So we get a plus 1.92. And then plus, so using the calculator again, well, I don't need a calculator for this one. This one is going to be 0.64. You multiply those. Okay. And then you got to add them all up. All right. So I'll do a few of them. So if you add these two, you'll get 2 plus, and then you got to put the rest. So this is 1.92 plus the 0.64. And then I'll just use a calculator to get the rest of this. So then our mean is going to be, let's see, 2 plus 1.92, that one's not bad, plus the 0.64. And we get that the mean is 4.56. So in terms of this example, the mean number of packs sold is 4.56. And it's okay for the mean to be decimals, right? So mean could be a decimal. What happened if you sold 1 2-pack and then 1 3-pack? If you take the mean of those, that's going to be 3 plus 2 divided by 2. That's 5 over 2, which is a decimal. So it's okay for the mean to have decimals here, even though these are nice discrete numbers up here. All right, so that's the mean. So next, we need the standard deviation, but I'll need to erase this to make sure we have enough room. So then we got that the mean was 4.56. Okay, and now we got to get the standard deviation. So again, the formula for the standard deviation, so first we find the variance, the population variance, which is sigma times x squared times p of x. So we do that first, and then we subtract off the mean squared. Okay, the population mean squared. So again, we have the probabilities. So we have this part. We know mu, we just found it, 4.56. And what we need now is x squared. So then I'm going to do another column up here, or row, and square the x values. So 2 squared is 4. 4 squared is 16. 6 squared is 36. And 8 squared is 64. It's right there. So our sigma squared, the population variance, is going to be, so you take the x squared and times it by the probability. So 4 times the 0.20 plus 16 times the 0.4. So 16 times the 0.40. And then plus the 36 times the 0.32. So 36 times 0.32 plus, you get the 64 times the 0.08. So 64 times the 0.08. And don't forget, like I did in the first example, to subtract off mu squared. So minus 4.56 squared. All right, so there's the lovely formula for the variance, and now we got to figure it out. And I'm going to use a calculator to figure out all of these right here. Okay, maybe not the first one. So sigma squared, if I multiply that, you're going to get 0.8, so 0.8 plus, so here I'll start using the calculator. It's not too bad, but 16 times 0.4, and we get 6.4. And if we do 36 times 0.32, 6 times 0.32, we get 11.52 plus 64 times the 0.08 is 5.12. And then minus, so then if you take 4.56 and square it, you get 20. So you get 20.79 to 2 decimal places. Okay, 79. All right. So then now we got to add these and then subtract off that right here. So sigma squared is going to be, so now you're going to take the 0.8 plus the 6.4. So just do it on your calculator, plus 11.52. And then plus the 5.12 and minus the 20.79 equals. There you go. So using a calculator, we get 3.05. And then to get the, so this is the population variance, but we want the population standard deviation. So then you have the square root. So sigma is the square root. Population standard deviation is the square root of all that, so therefore sigma is going to be, so I gotta do the square root of 3.05 equals. So the 2 decimal places, this is 1.75. There it is. So there's the population standard deviation for this probability distribution and the population mean. All right.